Assalamualaikum and very good day to all of you. So now we are in chapter 2, which is about the pressure measurement. Well, this is the content outline for this chapter, which is include pressure measurement and a basic concept about the pressure, which is between the pressure, absolute pressure and gauge pressure. And from that, we will learn about how can we determine the pressure from the elevation. And we also learn about Pascal's paradox theory. How can we determine the pressure by using the paradox theory, and few of the measurement device which usually used to determine the pressure. So at the end of this chapter, I expected that you know and able to describe few properties about the air at standard atmospheric pressure, and you will able to define the relationship between absolute pressure and atmospheric pressure, and you will also be able to determine the change in pressure by using elevation. And lastly, you'll be able to describe and distinguish a few types of devices which is used to determine the pressure. Before we can start to learn a few important parameters and few properties about the pressure, we have to know first what is pressure. So pressure is actually defined as a normal force exerted by a fluid per unit area. So for example, okay, we have uh, this piston, which of course maybe inside the piston contain air. Okay, so this air is actually considered as a fluid. Okay, so what is pressure? Here is defined as a force. Pressure is actually defined as a force, normal force, okay, per unit area. So the pressure in this direction, okay, which is 90-degree normal to the surface area. And for example, if we compare here, we have two different men, which is one with a weight of 70 kg and the other one is 140 kg. So of course, the pressure which is experienced on this surface is much higher compared to this surface, even though they both have the same size of feet. Okay, why? Because P equals to F over A, and F is actually can define as mg. So with the higher mass will contribute to the higher pressure. And that's the units of the pressure is also always defined as 1 Pascal, which is 1 Pascal equals to Newton per meter square. This is how it gets for the formula, which is the Newton is referred to the unit of force and meter square is the unit for area. And this is the list of the pressure in other unit. And we also will learn a few devices which is used to determine the pressure. In this slide, I summarize all the important parameters that we're going to use in this chapter. The first one is about the relation between the absolute pressure, pressure gauge, and atmospheric pressure, and also vacuum pressure. So first of all, what is the absolute pressure? Absolute pressure means that when we add the pressure reading, which is shown on the gauge, okay, plus with atmospheric pressure. Okay, so for example, there's a pressure gauge on the pipeline, okay, which is shows that maybe that the pressure gauge shows that it is 2 atm, okay, and then we know what is the absolute pressure. Okay, so the absolute pressure is we add the reading which is on the gauge, pressure gauge, which is 2 atm, plus with the atmospheric pressure, which is 1 atm, which is the pressure above the sea level. Okay, and what about the vacuum pressure? Vacuum pressure happen when the pressure it is lower than atmospheric pressure. So how to get the vacuum pressure? You can get it from this formula, which is atmospheric pressure minus with the absolute pressure. Okay, so this is the first part we're gonna learn in this chapter. And the second part is we're going to get pressure from the reading of from the elevation. Elevation here means H value. Okay, so for example, how can we get the pressure at point 2? Okay, point 2. Okay, if we have the atmospheric pressure at a certain value and with a certain level of the liquid. Okay, so that one we can explore in this part, which is the relationship between pressure and elevation. And the third part is we want to get the pressure or the area by using the equality of pressure at the same level, and this is the when we apply the Pascal paradox theory. Okay, and lastly we will explore how can we determine the pressure vertically in a fluid under gravity. Okay, so I will explain all of this later on in each different part. Part we will learn about the relationship between the absolute pressure and gauge pressure. So these two parameters actually can be summarized or can be calculated, determined by using these two correlation. Okay. The first one is absolute pressure equals to pressure gauge plus atmospheric pressure, and the second one is actually uh, the vacuum pressure, which is can be get by just minus between atmospheric pressure with the absolute pressure. So you only gonna get the vacuum pressure when the pressure it is less than atmospheric pressure. Okay, so absolute pressure is also known as the actual pressure. Okay, as I told before, the absolute pressure can be get by just summing up between the gauge pressure, which is the pressure which is shown on the measuring device or pressure measuring device, and plus with the atmospheric pressure. If it's above the sea level, and that one is considered as 1 atm or 101 kilopascal. This is again just summary about the absolute and gauge pressure. The gauge pressure is positive when it is greater than atmospheric pressure, and when you get the gauge pressure which is less than atmospheric pressure, so it's become negative, so it shows that it is under vacuum condition. Okay, and the pressure atmospheric pressure above the sea level, which is at 1.3 kilopascal, or also known as 1 atm. Okay, let's try example 1. Okay, so the question stated that one of the reactor under connected vacuum gauge has shows the reading which is 2.3 psi. Okay, so it is known that atmospheric pressure at that place is 16 psi. So calculate the absolute pressure in the reactor. Okay, so from the question, the statement here, we know that the gauge pressure, the vacuum pressure, is 2.3 psi. Okay, and then from question A, the question asks you to determine what is absolute pressure, in which that you know the atmospheric pressure at that condition is 16 psi. However, for question B, okay, it asks you to determine what is the gauge pressure. Okay, if the absolute pressure P absolute is 11 psi. Okay, stated here, and atmospheric pressure is 16 psi. Okay, so let's plan how can we solve the problem A and problem B. Okay, let's begin with the question 1A. So first of all, you need to draw the diagram. So we know that the atmospheric pressure at that condition is 16 psi. And the vacuum pressure, because remember that the question said that the vacuum gauge, okay, at 2.3 psi. So the question asks us to determine what is the the question asks you to determine what is the absolute pressure. Okay, so we know that we can use this correlation, in which that from this question we know that vacuum pressure is given, atmospheric pressure is given, so we just need to get what is the absolute pressure. Okay, so if we simplify the equation, we can say that P absolute is actually equals to P ATM minus with P vacuum. So once we already have all the information needed in the equation, okay, so we just substitute the value. So at the end, you get what is the absolute pressure, which is 13.7 psi. Very simple and straightforward. So for question 1b, the question asks you to determine what is the gauge pressure if the atmospheric pressure and absolute pressure is given. Okay. So again, we do the formula planning. Okay. So we have the absolute pressure and we want the gauge pressure, and the atmospheric pressure is given. Okay. So we just substitute the value, and then we managed to get the value of gauge pressure is -5. So once the gauge pressure, which is referred as negative value, it shows that this is under vacuum condition. Okay, so it's actually vacuum pressure. Okay, and even when we look at the atmospheric pressure, which is 16 psi, and the gauge pressure that we get is actually 5. Okay, so even though from the reading of the pressure we can see that the gauge pressure, the absolute pressure, is much more smaller than atmospheric pressure, so it shows that that reading is actually under vacuum condition. Okay, next part, which is relationship between pressure and elevation. So pressure, how the pressure can be related to elevation, which is H, or sometimes it's also referred as Z2 minus Z1. So for example, we have a liquid, okay, and this one refer as 0.2 and this one is 0.1, so Z2 and Z1. So Z2 minus Z1 is actually refers as the elevation. So how can the information about this elevation can be used to calculate the pressure? Derivation of the formula can be expressed from this diagram. So example, we have one bodies, okay, and which is pressure 2 is applied on the surface number 2, okay, and we know that this body will have weight on it, definitely will have weight. Okay, so due to the pressure here and the weight of the body, there will be another repulsive pressure, which is will rebounce back the pressure. Seems like the theory of human on the surface of the earth. Okay, so for example, you standing on the floor. Okay, so there will be force pointing downward, okay, due to the weight of your body. Okay, so what happened is there will be another force, gravity force, which is will repulse back, okay, in the same direction, sorry, in the opposite direction, but with the same magnitude. Okay, so from that pressure, this is how it didn't make you sink inside the earth or inside the floor. Okay, so the same concept refer to this one. Okay, the P1 is actually will be equals to P2 plus the effect of the pressure to the weight of the body. Okay, so as the pressure decrease, as the height increase, the pressure will be decreased. So the derivation of the formula is actually can be simplified through this equation. Okay, so force due to weight of the element can be determined through this formula. Weight equals to mg. Okay, so the g term here uh, is kept the same way. Okay, but only the m term. M equals to rho times V. Okay. Again, the rho term is maintained here. So the V is actually represent A. V is actually A times with the H, which is also referred as Z2 minus Z1. So if we equating between the upward and downward force, it will become like this. Okay. So force at point 1 will be equals to force at point 2 due to the point 2. Okay. So P1A is actually equals to P2A, which is pressure applied at the surface, plus with the pressure due to the weight of the body. Okay, and if we rearrange the equation in order to want to get the pressure difference between these 2 points, okay, we will get into this equation. Okay. So as a conclusion, if you want to determine what is the delta P between 2 points, okay, you can use this formula, which is delta P equals to Y times with the H, which is referred to elevation. Okay, and sometimes you can also rewrite the equation into rho GH. So both equations are correct. So it depends on you which equation that you are comfortable with it. Okay. So let's take a look at these two cases. Okay, so case 1 and case 2. Well, this is supposedly case 2. Okay, so case 1. Okay, so for example, determine the delta P, okay, between point 1, which is a reference point here, is at the bottom layer of the sea, and the water surface. Okay, so delta P will be Y times with the H. So in this case, H is referred as the H value height from the surface, from the water surface to the reference point. So in this case is 150 meter. Okay, so what about this question? Okay, so what about the second case? So in this case, you are required to determine the pressure, okay, the delta P between, so reference point now is become the submarine's point, okay. So between this reference point, okay, point 1 to the water surface. So in this case, Y times the H. H is actually measured from your reference point. So in this case, your submarine become the reference point, which is different to the case 1, where the bottom layer become the reference point. So as the submarine become the reference point, okay, so the H value is actually 90. Okay, so you see the difference? So the delta P or the is can be different, depends on the point of reference that you are chosen, right? Okay, so just now we already learned how can we measure the delta P between the 2 points. Okay, if we arrange the equation that we get from the previous slide, and we also have to consider um, the atmospheric pressure. Okay, so the delta P at a certain point is actually can be derived through the equation, which is P atmospheric plus with the delta P at a certain point. Okay, so the delta P is actually determined by the equation that we derived in the previous slide, and you can also express it in this term. Okay, like for example, okay, determine the pressure at point 2. Okay, so this is the water surface. So the pressure at point 2 is actually can be derived by P2 is actually P atmospheric, because this is under atmospheric pressure, plus with the delta P between these 2 points. All right. Okay, let's do this example. Example 1, which is consists of two questions, 1A and 1B. So determine the change in pressure from the surface of water in swimming pool to the depth of 5 meter and 15 feet. So both A and B requires you to determine the pressure, okay, in two conditions, which is the pressure you need to determine from the water surface to the depth of 5 meter. For example, the H1 is 5 meter. Meanwhile, for question B, this is for A, and for question B at the depth of 15 feet. Okay, so H2 at 15 feet. This is for question B. So you need to get what is the change in pressure between between point A, for point for at 5 meter and at the depth of 15 feet. Okay, so for question 1b, again, you have to draw the diagram, and we know that h in this case is equal to 15 feet. Okay, since that the information given here, which is in the unit feet, so what do we expect? So that means that the delta P must be in the unit of English unit. Okay, well, we know that we have to use this formula. Okay, and the h is actually in feet. Okay, but the y usually that we know is actually in the unit of pound over feet to the power of 3. Okay, therefore, if we just multiply between the two value, okay, we will get our delta P, which is in the unit of, okay, LB over feet to the power of 3 times with the feet, okay. So our delta P is actually in pound over feet to the power of 2, okay. However, for delta P in English unit, it is expressed in pound over inch to the power of 2. So you need to introduce a unit conversion, okay. So after you multiply, that means after you multiply 62.4, okay, with the h, which is 15, so the unit now become feet, the unit now become pound over feet to the power of 2. So we want to get the unit in pound over inch. That means this one need to change into inch. Therefore, we have to do unit conversion between feet to the power of 2 with the inch to the power of 2. So 1 feet is equals to 144 inch. Okay, so you just divide this with the 144, and then you will get the answer in the unit of pound over inch to the power of 4, which is 6.5 for delta P. This example, which is change in pressure, but this one is a little bit difficult because you have many points. Okay, so the question stated that shows a tank of oil in one side exposed. So this side is actually exposed, and the others is not exposed. It is sealed. Okay, And the specific gravity, the Sg of the oil is 0.9. So calculate the pressure at different point, which is A, E, B, C, D, and F. So A is here. Okay. Okay, and E, which is the same level as B. Sorry, the same level as A. And B, C here, and D, which is here, and F here. F, E, D, B, C, and A. So let's take a look at the solution step. Okay, let's begin with point A. Okay, so point A is actually on the top surface of the oil. Okay, so the pressure here is equals to 0 because it is experienced only the atmosphere. It is exposed to atmosphere. So the pressure here at this point is equals to 0. Okay, it is open. And what about point E? Since point E is at the same level as A, so it's also considered as 0. Okay, because there is no elevation, so H equals to 0. Okay, let's do for point B. Okay, this is point B. Okay, and the distance between A and B is actually 3 meters. Okay, so B is lower than A with H equals to 3 meter. The elevation is 3 meter. So we know that we have to use this equation. Okay, so the H is 3 meter and the Y, which is can be get through this formula. Okay, remember that before this we learned that the Sg is actually the ratio between the specific weight of the solution divided by specific weight of the water at 40 kc. Okay, so in order to get the Ys, you just multiply between the Sg and the Yw. Okay, so you get the Y oil, and then from that we can determine what is the delta P between A and B, which is Y oil in this case is 8.83 times with the H value in this case is equal to 3. H equals to 3 meter. Therefore, you get the delta P between point A and B is actually 26.5 kilopascal. Okay, so the pressure at point B is actually the difference pressure between point A to point B plus with the atmospheric pressure at A, okay, which is in this case is equals to 0. The pressure above here, which is equals to 0. So it's become 26.5 kilopascal, which is will be the gauge pressure. Okay, let's do the next point, which is point C. Okay, if we look at this diagram again, okay, the distance between A and C is 3 plus 3, which is H equals to 3 meter. So C is lower than A at H equals to 6 meter. Okay, so again, we have to use this formula in which that we know that H will be 6 meter. Okay, same again with the Y all, we just use the same procedure as we determine the Y all at for point B. Okay, we just multiply the Sg value of the oil, which is 0.9, with the Y for water. Okay, so you get the 8.83. Then we get the delta P between point A and point C, which is in this case equals to 53 kilopascal. Therefore, the pressure at C is equals to pressure at A, okay, PA, plus with the difference in pressure between point A and C, which is that we calculate just now, equals to 53 kilopascal. So at the end, the pressure at point C is actually 53 kilopascal. It's quite similar to the point B, and the only difference is actually the H value. Well, next one is point D. So if we notice that point B and D is actually the same level. So when the point is at the same level and in the same types of the liquid, so pressure, definitely pressure at B will be equals to pressure at D, which is 26.5 kilopascal. So this one we already calculate in question B. Okay. Okay, last one, which is at point F. Okay, so the point F is here. So from this diagram, it shows that our reference point, which is A, is lower than F, which is it is lower about 1.5 meter. Okay, so because A is lower than F at H equals to 1.5 meter, we're still going to use this equation. However, the H here, because it is lower than our reference point, so H here is actually supposed to be negative 1.5 meter. So if we want to get the pressure difference between A and F, okay, same again, we just use the same value of Y. But the H value here, you have to put the negative value because it is our reference point is lower compared to the our point that we want to measure. So it's become negative. So pressure at F is actually equals to PA plus with the difference between pressure between the pressure difference between point A to point F. Okay, so at last we get the pressure for point F is actually minus 13.2 kilopascal. That's it. Hope you can understand it well. Okay, we come to the end of this part 1 and part 2. Okay, look forward to see you in the next part. Bye.